The planet is spinning right now at roughly 1,770 kilometers per hour at the equator. You cannot feel it. You have never felt it. Your entire life has been lived on a surface, moving faster than a bullet. And your body has no sensation of it whatsoever because everything around you, the air, the water, the ground, the atmosphere, is all moving at exactly the same speed in exactly the same direction. Now, imagine it stops, not slows down, gradually over millions of years. The way geophysicists tell us, it actually is decelerating by about 1.4 milliseconds per century, too slow to matter in any human lifetime. Imagine it stops suddenly, today, right now, in the next few seconds. What happens next is one of the most violent, comprehensive, and total catastrophes that physics can produce on a planetary scale. And understanding it requires understanding something most people never think about. The Earth is not the only thing spinning. Everything on it is spinning with it. The atmosphere, the oceans, the molten core, every building, every mountain, every living thing on the surface, all of it has momentum. All of it is moving at up to 1,670 kilometers per hour relative to the axis of the planet. When the surface stops, that momentum does not disappear. It has to go somewhere. The first thing that happens is the most immediately deadly. Everything that is not bolted to the bedrock of the planet, which is essentially everything, continues moving at 1,670 kilometers per hour while the ground beneath it stops. This is the same physics as a car hitting a wall. The car stops. The passengers continue forward at the speed the car was traveling. At the equator, where the rotational speed is highest, every person, every animal, every building, every vehicle, every loose object on the surface becomes a projectile flying eastward at roughly 1,670 kilometers per hour. That is faster than the speed of sound. The people at the equator do not fall over. They are launched horizontally at supersonic speed. Further from the equator, the speed is lower because the distance from the rotational axis is shorter. At 45 degrees latitude, the speed is around 1,180 kilometers per hour, still catastrophically fast. At the poles, the rotational speed is essentially zero. The poles are the only places on Earth where you would not immediately become a supersonic projectile. But the poles would not be safe for long, because the atmosphere is also spinning, and the atmosphere does not stop when the ground does. The air at the equator, all of it, the entire column of atmosphere stretching from the ground to the edge of space, is moving eastward at 1,170 kilometers per hour. When the ground stops, the air does not. The atmosphere continues moving, while the surface beneath it is suddenly stationary. The result is the most powerful wind event in the history of the planet. Winds of 1,770 kilometers per hour, nearly 5 times the speed of the most powerful tornado ever recorded, scour the surface of the Earth at the equator. These are not winds that blow things over. These are winds that remove the surface, rock, soil, water. Anything that was not deeply embedded in the bedrock of the planet is stripped away and carried eastward. The oceans are doing the same thing. All the water in the oceans has momentum. When the rotation stops, that water continues moving eastward. Tsunamis of unimaginable scale surge toward both eastern coastlines everywhere on the planet. Not the kind of tsunamis we have measured and mapped. These would be walls of water hundreds of meters high, moving at hundreds of kilometers per hour, carrying everything they hit far inland, then pulling everything back out to sea when the water redistributes. The redistribution itself is catastrophic in a different way. Right now, the spinning of the Earth causes the oceans to bulge at the equator. The equatorial ocean surface is actually about 21 kilometers higher than it would be if the planet were not spinning, because the centrifugal effect of rotation pushes water outward from the poles toward the equator. When rotation stops, that bulge redistributes. Water that was held at the equator by centrifugal force moves toward the poles. Enormous floods, not from waves, but from the fundamental reshaping of where the ocean sits on the planet, cover enormous areas of land that are currently dry. The geography of the Earth changes. New coastlines appear. Old coastlines disappear. Large parts of what is now land in the Americas and Southeast Asia and coastal Africa go underwater, not from a wave, but from the ocean, simply spreading to fill a different shape. Now, let us go underground. The core of the Earth is also spinning. The inner core is solid iron and nickel, and it rotates slightly faster than the rest of the planet. The outer core is liquid metal, convecting in enormous currents that generate the Earth's magnetic field. All of this has angular momentum. When the surface stops, the core does not stop immediately. The coupling between the surface and the interior is not rigid. The core continues rotating while the crust decelerates. The shear forces between the still rotating interior and the suddenly stopped crust create earthquakes of a scale that has no historical precedent. Every fault line on the planet activates simultaneously. The crust does not just shake, it tears. Volcanoes that have been dormant for millions of years erupt simultaneously as the pressure dynamics of the interior change catastrophically. The dust and ash and gas released into the atmosphere by thousands of simultaneous volcanic eruptions would, even in the most optimistic scenarios, block enough sunlight to cause a global temperature drop within months. The volcanic winter would last years, possibly decades, but all of this is secondary to what happens to the day. If the Earth stops spinning, the day becomes a year. Right now, the Earth rotates once every 24 hours relative to the sun. That is what gives us day and night. If rotation stops, one side of the Earth faces the sun continuously, while the other side faces permanent darkness. The day side bakes under continuous solar radiation for 6 months, the time it takes the Earth to move halfway around its orbit. Then, the geometry switches, and the formerly dark side gets 6 months of continuous daylight. The day side reaches temperatures that make deserts look comfortable. Without the moderating effect of a day-night cycle, surface temperatures climb steadily as heat accumulates. Soil bakes dry, liquid water evaporates. The atmosphere on the day side becomes superheated. The night side freezes. Temperatures plunge to well below minus 100 degrees Celsius in the absence of any solar energy. The atmosphere itself, at those temperatures, begins to condense. Gases that normally stay in the atmosphere start freezing out and falling as liquid or solid. The air on the night side becomes thinner, denser, colder. The difference in atmospheric pressure between the baking day side and the freezing night side creates permanent catastrophic winds that blow from the high-pressure night side to the low-pressure day side. These winds carry heat and cold across the terminator, the line between permanent day and permanent night, creating a narrow band around the planet where conditions are survivable, a thin strip of perpetual twilight that moves slowly around the Earth as it orbits the sun. This twilight band is the only place on the post-stopped Earth where liquid water could theoretically exist, where temperatures would be neither lethally hot nor lethally cold, where some form of biological activity could, in the very long run, potentially continue. But getting there from here would require surviving everything that came before: the supersonic winds, the mega tsunamis, the simultaneous earthquakes, the volcanic eruptions, the atmosphere being stripped and redistributed, the oceans reshaping themselves across the surface of the planet, the magnetic field destabilizing as the core dynamics change, the radiation exposure that follows when the magnetic field weakens, The honest answer to what would survive a sudden stop of Earth's rotation is almost nothing. Not because life is fragile, though it is, but because the specific conditions that support life on this planet, the day and night cycle, the moderate temperatures, the stable ocean distribution, the protective magnetic field, are all consequences of the rotation. Take away the rotation, and you take away everything that makes the surface of this planet habitable. The good news, if you can call it that, is that there is no known mechanism that could stop the Earth's rotation suddenly. The physics does not allow it. A collision with an object large enough to stop the rotation instantly would itself be so catastrophic that the question of what happens after becomes academic. The Earth as a coherent body would not survive such an impact. The Earth will continue to slow. One day, in the very deep future, it may become tidally locked to the sun, the way the moon is tidally locked to the Earth, always showing the same face. But that is billions of years away, long after the sun has entered its red giant phase and rendered the surface uninhabitable by any of the mechanisms we have described. For now, the planet spins, silently, imperceptibly, at 1,670 kilometers per hour, and the fact that you cannot feel it is perhaps the most remarkable thing about it.